Hi everyone. In this video, I am going to be going through a series of hands-on labs from the CCNA Routing and Switching Study Guide written by Todd Lammle, Lammle. These are at the end of Chapter 7, and this goes through configuring, backing up a router configuration, using the Cisco Discovery Protocol, CDP, using Telnet from a Cisco device to another device, and resolving host names. In the book, it recommends doing this with hands-on physical hardware, all of the proper cabling and everything. That's a little bit difficult to record, so I wanted to go ahead and do this in Packet Tracer. So, to begin, we need to have some kind of network set up, and I think I'm going to go a little overboard, but that's okay. So I'm going to get this set up the way I think a generic network might actually be set up. So I'm going to have a few routers. I'm sure I'm going to end up having a couple switches. And for part of this, we need an FTP capable machine. In Packet Tracer, that means you have to use a server in order to set up TFTP or FTP. The desktop alone can't do it, but I'll go ahead and throw a PC in there just for simulating a network on that side. There wasn't a whole lot of guidance given beforehand, so I just arbitrarily picked a network to start with. So I'm going to be using the 10.25.0.0 as a /22. And so that's going to be my base network. And I do also want to emulate an internet connection. Alright, so I kind of want a variety of cabling set up through here. So I'm going to begin by setting these two routers up with serial interfaces. So we'll need to shut them down, add in the serial connectors, and boot them back up. Okay, while they're doing their thing, I'm going to go ahead and start cabling everything else up. So from our edge router here to connect to the internet, I'm going to go ahead and just use a copper straight through. What you actually end up using in a live network will depend on your ISP, whether it uses fiber or phone line or cable. I'm not too worried about it. That's just an emulation. I'm not even going to touch that part beyond this configuration. From my edge router, and let's go ahead and get these named really quick. Just to make it a little bit easier, I'll have it display the same name so we can see what it is. For this router, since it's not an edge device, but it looks like it'll be kind of the primary router, the way I'm currently setting it up, to cable everything here, and then cable everything here directly to this router. It's kind of going to be the primary gateway, the primary router in my network. So I'm going to give it the host name prime. And I'll do the same thing to make the display match. And for this final router, the way I'm going to be subnetting is I'm going to have this portion of my network as a /23, and then over here will be a /24, which is a class C. So I'm just going to give it the host name classy and have it display the same. Alright, so we want to finish cabling. So to begin, we'll go from our edge down to prime. We'll need a crossover cable connecting two like devices in Packet Tracer. And then here, I set up those serial connections, so we'll use a serial cable. And then from our routers to our switches, we will use some straight-through cabling. On this side, we'll be doing the same thing with straight-through cabling. And then we'll go ahead and hook up our server and our PC. Alright, so we've got a lot of red, which usually is a bad thing, but it should be expected because all the router interfaces are turned off to begin with. So one thing I want to do, I went ahead and did the math already to start subnetting. Before we jump into that, let's go ahead and do a little bit of naming here. This is going to be FTP Server, since we'll be using that. PC0 doesn't really matter. I don't plan on doing anything with it besides pinging to make sure I have connectivity. So I'll just do PCA. Alright, so the ISP side, I'm really not concerned about IP addressing. That's something I would have to work out with the ISP. I'm not even going to bother getting into that, but I can start doing my devices next. So based off of this network, I'm going to use that subnet for those two routers. And between these two routers, I'll go ahead and set this up as a 1025.30. So that way my in-house routers start at the bottom, my gateways out will be up at the top. And then this actual LAN will be 1025.20 on a /24, has an actual class C. And then this side of my LAN will be my larger side where my servers will reside and most of my users. And it'll be 00 on a /23. So it looks like I have most of my subnetting taken care of. I'm going to go ahead and get everything online and IP addresses set up. So we're going to go ahead and start with the FTP server because it's going to be very important. I'm going to let it have a static address, and I'm going to come over to the desktop to set up the IP configuration. The FTP server is going to be 10.25.0.5 with a /23 subnet mask. And I want to make sure that I do assign a default gateway here. And this gateway is going to be my prime router on this side. So this interface is going to be the next one that I go ahead and configure. And this is on interface G01. And I'll go ahead and bring it online. So I have full connectivity here now. Since I'm in Prime already, I'll go ahead and move towards this section of my network. So the serial interface will be 1025.3.1 as a /30. And since that's a DCE serial interface, I'll also need to go ahead and give it a clock rate. And we'll come back to do the edge side. I'm going to go ahead and continue. So I'm going to do my Class C serial interface. Because it is the DCE and I gave the clock rate on this end, I don't need to give it again here. Alright, and then on my Class C router, to actually enable traffic from my LAN, I'll need to give an IP address and enable G00. as a class C/24. Alright, and then I'll need to assign an address for PCA. I don't plan on having any DHCP set up, so all of these will be static addresses. And the gateway will be the class C router. So once that comes up, I should have connectivity there. And I don't have any routing protocols or anything set up yet. We'll get into that once I finish the edge side here. So I'll start in prime on the G00 interface. And it'll need an address. As a /30. And then I do the same configuration on the edge router itself. I believe it was on G01. Let me verify that. G0 is, sorry, this interface, there we go, G01. Give it the no shut command to bring it online. And then just for kicks, I'm just going to bring this online without an address, because that would be configured, hopefully, DHCP from the ISP. Otherwise you'd have to statically assign an address and some routing protocols depending on your ISP. Alright, so everything looks good. We've got a lot of green now. For the most part, our pinging to our immediate gateways should be successful. But again, with no routing protocols, we might not have any luck going across networks, going through multiple routers. And so that's the next thing that we want to do. I'm going to go ahead and do this quickly with OSPF. ID 10. And so I'll have the edge will be ID 1111. Prime will be ID 2222. And classy will be 3333. Alright, so it doesn't really matter where we begin. I'm going to go ahead and start with class C. I'm going to be the global configuration mode, and I want to start setting up OSPF. And then we need to give the network for each directly attached interface. So class C has two networks. The first is 10.25.20 as a /24, and for these we'll be using the wildcard mask, not the standard mask. So the wildcard is just the inverse of the regular mask. As a /24, we're used to seeing 255, 255, 2550. For the wildcard, we just invert it completely. So instead it'll be 0, 0, 0, 255. Next, we need to go ahead and make sure that we give it an area. I'm going to put all of these in area 0 just to make things simple. In a real environment, you may not do that, but again, that depends on your network. And then the other network connection directly attached is 10.25.30. And then I want to go ahead and give it a passive interface for the LAN side, so it's not broadcasting routing information to the PCs that don't need it. And so G00 will become a passive interface on here. Alright, so now this section should be pretty much set up. Next I'm going to go ahead and do prime. Get back to the global configuration mode, and we're going to go through the same process. Router OSPF ID 10. Then I want to give the router ID 2222. Configure the network statements. be the same. Let me get that back down here. Passive interface. Again, the passive should be the LAN side to the user computers and machines, G01 in this case. And then the last thing I'll need to do is configure OSPF on the edge router. And again, so I'm not touching anything out to the internet side, so I'm not going to worry about passive interfaces or anything like that on here. And once we allow those to initialize, we should be able to ping across routers, across the network, pretty much all the way through. And the reason I wanted that ability is because the first hands-on lab, now that we have our network built up, the first hands-on lab is to back up a configuration with FTP or TFTP. So really quickly, we're going to come look at my TFTP services and see that it's enabled, which will allow us to save using TFTP. If I want to use FTP, then I have to use credentials, username and password. So let's take a quick look, save from the edge. The first thing I want to do is copy my running configuration to my startup configuration. That way I have a file for startup, and I'm going to try to copy that startup file to my FTP server. So the next thing to do that is the command copy run or copy start, either one, TFTP, and hit enter. It'll prompt for the address or the name. I'm going to use the address because I don't have any kind of DNS set up yet. So this is going to be the address of that FTP server. It'll ask me to confirm the file name, and then it will transfer. So TFTP is really straightforward. It just kind of sends it along. Now if we wanted to use FTP, we would go about it the same way, but we'll get an error because we haven't given any credentials to use FTP. So to do that, we'll get back into the global configuration mode, and we'll do IP FTP, I believe it's host name, username, as Cisco as it matches on the FTP server. Again, if we wanted to do something else, we would just need to add credentials for that user on the FTP server. For example, if I wanted to use Scott with the password of Scott and give myself full control, then I can configure that on the router as well. So let's go ahead and do it that way. So I create the username, then I need to set my password, and then I should be able to save using FTP, and it will use these credentials by default because it's the only credentials it has. If you do not give any credentials, it tries to connect anonymously. So if the FTP server is configured to reject anonymous connections, then you will get that error that username and password is not set, or that your connection has been rejected, something along those lines. Alright, so it looks like that was most of 7.1. And the next lab is 7.2 using Cisco Discovery Protocol. Before I jump directly into that though, this worked because I have my routing protocols enabled. If you don't, you can always do a directly attached, or if you're working with a limited amount of hardware, but you have a router and a computer that can handle FTP or TFTP, you can always connect them directly, well, if there is a port available there. You connect it just like that with, you don't use a crossover cable, but from your server to directly to your router, and you could do your FTP transfer that way as well. So in this network, I chose the edge to test because it would be the most likely to fail. Now that I know it works, these others shouldn't be a problem, so I'm going to go ahead and move on to 7.2, which is the Cisco Discovery Protocol, CDP. And let's go ahead and take a look from the prime router, because we should have the most information set up here when we look at it. So we'll come back out, and we're going to do the show CDP command and hit enter. This is the general information. We are sending CDP packets every 60 seconds. We hold for 180 seconds, and CDP version 2 is enabled. So this means that every 60 seconds we kind of check in, or this router will check in with its neighboring devices, and they will, if they're configured the same way, they'll check back in with this router every 60 seconds. So this router will hold that information for 180 seconds, and if the next device over, for example, the Class C, will check in every 60 seconds back to Prime, and Prime will store a record that Class C is there, the IP address and interface and everything, and we'll look at the specific details. But if Class C is checking in every 60 seconds, Prime will hold that information for 180 seconds. So if Class C misses 2 check-ins, then he'll be approaching that 180 seconds. If he misses that third check-in, then Prime will drop that information. So let's take a look at what exactly that information is. With the show CDP neighbor, my shorthand for neighbor there. And so we have a switch that I didn't bother renaming, connected locally on G01 on this router. And there's our hold time. So you take 180 minus that hold time, and that tells you the last check-in. The capability, the key is right above. S is for switch, R is for router. It'll also give you the platform, which is the model, and the remote interface. So I'm connected to G01 on the switch. Class C is my other router. It's a serial connection all the way. Again, same information, and same thing to the edge router. Connected to G00 locally on Prime, and connected to G01 on the edge router. So that's the kind of information you can get with that. We can do a little bit of configuration there. There was one more thing I wanted to take a quick look at. If you use neighbor detail, then you can get significantly more information about each of the neighbors. So you see I gave the command here, so it's going through first through the switch. There's no addressing on the switch, but it still identifies the interface, the hold time, the software version, so the iOS that device is running. And then we can move on to the next one, is the Class C, which is the other router. And we can see that we can get the IP address for it that way. And again, it'll have the same information, the interface in use. Come back up, there we go. So the interface that's in use, the hold time, the software and iOS version. And it'll do the same thing for the edge device. Give us the IP address, interface, and software and iOS version. So it's a really good, really helpful troubleshooting tool if you need to map out your network. That can be very helpful. So let's go ahead and just run this again. So we have our global CDP information with our packets and our hold timers. We can actually configure this so that we send these CDP packets every 90 seconds or 120 seconds, just to reduce the amount of overhead. for maintaining this information. So we can come up to our global configuration and give the command cdp timer, and let's see if it will. So it looks like on this older version of the iOS we can only enable or disable. In newer hardware you can actually configure a timer for 90 seconds, 120 seconds, whatever you'd like to do for your network. I don't recommend increasing the timer above the hold timer, because then it's just going to be dropping the information and then rebuilding the information. It's going to end up taxing the hardware a little bit every time it has to do it. So to reduce your overhead, again, you can increase this to 90 or 120 seconds without any problems. Let's see if there's anything else that we need to cover for CDP. We can go ahead and take a look from one of the other devices. So example from the edge. We can get the global information again, so the send time, or the send frequency, and the hold time. We can see our neighbor, which currently is only going to show prime because there isn't actually any devices up in the cloud. It's just to simulate the internet connection, but it will show us prime. And if we did the full detail command, then we can get all the information that we can pull from prime that way, including the IP address of prime, interface, and the software and iOS version. Alright, so that pretty much covers 7.2. So moving into 7.3 using Telnet. Telnet is the less secure alternative to SSH. So let's say I am directly connected to my Class C router, but I really wanted to Telnet into my Edge router. First we'll need to be inside of the Class C router. And then we should be able to Telnet into let's go 254. We'll try to Telnet into prime first. And we see that it was rejected immediately because I haven't enabled any VTY lines. So, back in prime, we will enable our VTY lines. Let's just go ahead and do all of them. Make sure they're okay. So we'll need to enable a password. You could enable a secret. That way we have a login capability. And that will allow us to Telnet from one router to the other. If we wanted to come back the opposite direction, I'd need to enable the VTY lines on Class C. So if we want to get up to Edge, we'll again need to do the exact same thing. Just to add a little bit of security there. Since we're in Class C, telnetted into prime, we can exit to come back to Class C, or we could continue telnetting from one to the next to the next. So now we're actually accessing the edge router through Prime rather than just kind of building it directly. And again, we can do exit to come back out and exit to go back out again. And then just to show that it will work, Telnet directly into the edge device from Class C. If you are telnetted from one device to another, you can use Control-Shift-6 and then hit X to come back to your own, your first device while maintaining that open connection to the other. So now it looks like I'm back able to configure the Class C router, but that connection is still open to the edge router. So let's go ahead and telnet back into my Prime router. Alright. And then I'm going to come back to my Class C. So I'm only configuring Class C at the moment, but I have an open telnet connection to both of my other two routers. So from here we can give the command show sessions and see those two connections that are open. If I was to exit one of those, then it would not show when I gave this command. So for example, from Prime now, we're not telnetting out from Prime, so it's not going to show here, but we can give the command show user and see that there is a connection that is incoming. So there's nothing on the console line, but on VTY line 0, I do have a connection that is open. From inside this router, if we want to close that connection and then add more security, you can do so, I believe, with the command clear line 0, VTY 0. No, it's just clear line 0. TTY. Sorry, 134. There we go. Let's try that. Nope, still won't take it. So maybe that's something that's more useful on the newer routers. Doesn't look like it will allow me to force that disconnect on this end. So in any case, we'll go ahead and come back to Class C. Let's see if it'll let us clear here. So again, it's the same thing. Doesn't look like it's quite robust enough on the older models to give one command to disconnect them all. So I'll just come back into my telnet. And close it that way. There we go. So unfortunately, that one command did not work. But in theory, in the newer devices, that command will disconnect the incoming connections, the incoming Telnet connections. Alright, moving on to the hands-on Lab 7.4, resolving host names. It does mention that it's best to use a DNS server, a little more power. So we could set up a DNS server to handle all of our host name lookups. In the event that our network doesn't have one, or it's just not ready to be placed yet, we can do some kind of more basic DNS tabling on our individual routers. So let's start with our edge, for example. So we have our host names, and we want to build a host table. We'll be doing that with the IP host command. And so you'll give the host name, for example, FTP Server, and then the IP address. So let's come back and let's try to ping by IP address, and we have success. And then now that I have a host table with a record for the FTP server, I can also do it by host name. But if I tried to ping, for example, my prime router, it doesn't know how to translate that to an IP address. Since there's no DNS, it tries to look it up and fails miserably because there is no DNS. So eventually that will just time out. One thing you can do to prevent it from doing that is in the global configuration mode, give the command no IP domain lookup. And then if we ran that ping again, it just will not recognize. That way you don't have to sit there and wait for it to time out. But if we want to, we could always add prime to its local table. And then if I wanted to test a ping to prime, it knows internally how to convert that to an IP address. These internal tables don't replicate, so if I was in prime and I tried to ping the FTP server, it doesn't know how, because it doesn't have that internally configured yet. So I would recommend having an actual DNS server. If you don't have one and you have multiple routers, you'll need to configure internally each host that you want to be able to contact by name rather than IP address. So there's quite a bit more work without some form of DNS service running on your network. Alright, let me see. And then the one thing you can do to verify those is give the show hosts command, and it'll show host name here, IP address over here. Perm means permanent, which means it was manually configured. It did not pick that up dynamically. If it was dynamic, it would say temp, temporary. And I think that pretty much covers everything for Chapter 7, at least briefly. As always, if you have any questions, comments, concerns, please feel free to leave them for me below, and I will try to reply in a timely fashion. Thank you for watching this extraordinarily long video, and I hope to see you in my next one.